Today, in this video, we will discuss why we need Retrieval-Augmented Generation, or called as RAG. So we know LLMs. LLM stands for Large Language Models. So large language models are good at generating or completing the sentences. Like if you say a cat sat on a wall, just if you want to LLMs to ask to generate, it can easily generate wall. So it is good at predicting the next word. So that's what LLM was good at. So how they are getting these things like predicting the next word or generating the sentences? So they are trained on a massive amount of publicly available data sets. So for each LLM, for example, let us take GPT-5. So they have their own cutoff date. So what is cutoff date? Cutoff date is the date where at that point of instant, whatever the publicly available data is there, they might be trained on that one. So that is called cutoff date. So for example, GPT-5 will is having a cutoff date of 2024 October 1st, and then Claude, this is from Anthropic, it's having a cutoff date of 2025 until July, and Gemini 3.4 having 2025 January. So now what happens to the knowledge after the cutoff date? So definitely it doesn't have any exposure to the knowledge after the cutoff date. So it doesn't have any knowledge like whatever you want to ask based upon the recent events. Definitely it doesn't have. So that's one main drawback in large language models. So to overcome this, there are we already discussed, like LLM is trained on a large amount of data, and then that trained LLM, we call it as pre-trained model. Okay, so it is pre-trained on a specific set of data set, or we can say a publicly available large amount of data set at that point of instance. So that is what we call as cutoff date. From that point to backwards, it has all the information, but from that point, from cutoff date to from cutoff date, that doesn't have anything. So it does have only the knowledge about the existing events or data which is available prior to the cutoff date. So we already discussed this, like they are good at generating sentences or words. Basically, they are predicting, like based upon their trained knowledge and also the neural networks. So it is good at predicting the next word. So that's what LLM was used for, like we can say a large language model. So now let us assume that there is a business user where you want to know the Q4 results of their own business. So LLM doesn't have that knowledge because it is not publicly available. First of all, if the data is publicly available, and that too if the data is available prior to the cutoff date, then only it can able to answer the question. If it doesn't have, then definitely it is not going to answer the question. So sometimes what happens, it may, if it is have a proper prompting, like it doesn't want to hallucinate, then it won't give you the correct answer, and it will say it doesn't know. But if it also try to hallucinate, like for example, it may give you a random answer, compelling random answer that it looks like a true answer, but it is not correct answer. So that's what we call as hallucination. Even though it doesn't have the knowledge, it try to come up with an answer, and that answer is definitely not a correct answer. So this is a problem where in most of the business use cases where we cannot directly use the pre-trained model. So pre-trained model is good for general purpose, and then it has the knowledge only whatever it was trained, and definitely doesn't have the knowledge of privately available data or your own business data. So then how we can use this in the business workflow or in our own scenarios, business scenarios where we can leverage LLMs. So somehow we need to give the knowledge, whatever knowledge we are going to ask. So that knowledge has to be given to the LLM. So then it can able to generate the answer based upon the knowledge what we have given. So how we can do that? So we need to provide the private knowledge or the business knowledge to the LLM. So there are two broad ways to accomplish this task. One is fine tuning, the other one is RAG. Okay. So before discussing about RAG, we will discuss about fine tuning. Okay. So fine tuning. Okay. So we already know that the large language models are pre-trained model. So how they are pre-trained? So they are pre-trained based upon the knowledge which is publicly available, and from that data set only the LLMs are trained, and so that this pre-trained data set, the data set which was used for pre-training, it was huge, like it is publicly available in the internet, and it was very huge. So in each and every domain they have the knowledge. So that's why if you ask any question, in general question, something like in a business or like what in the finance, whatever you want, if it is a general question, you can able to answer the question properly, because the knowledge it has from the pre-trained. So it get that and then give the or provide you a very good answer. There is one particular technique called prompting that we will discuss later. So how you ask questions, so based upon that it will give the answer. So the way you ask the questions, that depends more on how quality the answer comes out from that particular large language model. So that's for a different video we will discuss. Now, so we already know that what is a pre-trained model. So now we take one pre-trained model, like any pre-trained large language model, and then we do fine tuning. So why we do fine tuning? We already discussed. We need to provide the business knowledge or the private knowledge which is specific to that business or specific to that particular use case. Then we fine tune. Fine tune means, so we take the pre-trained model and a small domain specific data has been added, and then fine tune it. This is a pure technical process where it requires technical knowledge, and then and also it is not cost efficient. Okay, so it requires a considerable amount of computing resources as well. Definitely it is costly. So now once we have the pre-trained model fine tuned to a specific data set, that is your business data set or any specific data set which you want answers from, then we get the fine tuned model. So this is for example, let us assume there is 100% of pre-trained model. In that 100%, we specifically tune or adjust the parameters of those model such that it can have the specific knowledge of your own business or your own use case. So that's how we do, okay, fine tuning. So generally the fine tuning will have it incur training costs, since you need a lot of compute resources, and also especially a trained engineer need to train it, and then once it was trained, there are different steps. It is more and more technical way. So once it is trained, then it will have your own business data. So while you are doing or fine tuning the model, you are giving a specific set of your own business data, right? So at that point, what you are tuning or what you are feeding into the LLM, so that's only the data set which it has its, for example, if you can ask questions on based upon this specific data sets, it can able to answer. Okay, So keep in mind. So we will come back to here. And the second one is it needs periodic retrain, okay, to stay updated. So as we discussed earlier, while for example you are doing a fine tuning today, okay, so whatever you have data feeding into this particular fine tuning process, only that knowledge will be preserved in this pre-trained LLM. That is, finally we get a fine tuned LLM. But after that, for example, 1 month from now, you want to add more data, or you want to know that LLM should answer the data whatever you have it right now, then definitely it can't able to answer it. Why? Because it doesn't have that knowledge. So in order to do that, then again you need to fine tune. So obviously the cost will be there. So that is one way of feeding your business knowledge to the LLM. There is one other way, like how we can able to do is using RAG. RAG stands for Retrieval-Augmented Generation. I will explain a simple process like how it can be accomplished. Okay. So now the business has a lot of documents. The documents may be in the form of PDF, Word, even Excel, images, whatever may be. So we all consider that as a documents. Okay. So now once we have those documents, we should have a system in such a way that it should parse the document and get the relevant information in the form of text or whatever way it may be. If it is an image, you get the image or the description of the image or whatever may be, and then you need to store those text or the particular data in the form of vectors. Okay, so vectors is like nothing but the LLM understandable language. We are converting the text, for example, into vectors, which can be easily understandable by the large language model. Okay, so once this conversion process is done, then we store that one into vector database. Okay, so now we have the knowledge in the form of database, that is vector database, which can be easily understandable and accessed by the LLM which you are going to ask the question. Okay, now when the user asks a question, let us assume that the user asks the same question like what are the Q4 results, or what will be the Q4 results looks like for this, like whatever may be, which is more specific to your business. Since you have the documents here and then you converted those knowledge in the form of vectors and then stored in a vector database, which can be easily understandable by the given LLM or the LLM what going to use to answer the question, the user asks the query. Okay, either it may be a finance or whatever may be, like what is the inventory level in my warehouse or to this particular warehouse 101. Since that knowledge is stored in the form of vector database, the user query will be taken and converted into vectors, and based upon the user query, it will search the vector database. Okay, so once it searches the vector database, it gets a relevant context or relevant data required to answer the question. Once it gets the relevant context, then the relevant context, okay, so we feed the context and then the user query to the LLM. Okay, so this LLM now, so this one is not a fine-tuned LLM. This is general purpose LLM, which we can say like a GPT-4 or Claude 4.5, Sonnet 4.5, any LLM. Okay, any general purpose LLM. So what we are doing here is we are giving the context, like for the particular user question, we are giving the context, and then both combined we are giving it to the LLM. So what happens now? The LLM gets the question, user query, and also it gets the relevant data to answer the question. So the LLM is good enough to read the question and it also has the context or the data from which we can get the questions. So now once that is given to the LLM, like user question and user context, we will get the response. So LLM now has the enough data to answer the question. So obviously the user will get the correct response based upon the user query, since it got the correct context, and then from that context only it is going to answer it. So that's how we generate the response based upon the user query. And this framework, what we call it as Retrieval-Augmented Generation. Okay. So how we do? So we have the user query. It goes to vector embeddings, and from the vector embeddings it goes to it was converted into vector embeddings, and then the user query also converted vector embeddings, and then the relevant context was picked up from the vector database, and those contexts are fed back to the LLM along with the question. We get the response. Okay. So here the data was retrieved based upon the user question, that is called data retrieval or retrieval, and we are augmenting it along with the user question and getting the context from the database, and both are augmented and finally generating the answer. So the LLM will generate the answer. So here we get the correct response. So this is a very basic framework how we can implement Retrieval-Augmented Generation. But in order to get a most accurate or most relevant answer to the user question, there are a lot of steps we need to do even in Retrieval-Augmented Generation. It is not a straightforward way, because there are different scenarios where the questions may get wrong, like the user may not get the correct questions. So when the user asks the query, okay, so that query has to be converted into vector embeddings, and semantically similar matching records has to be fetched up. Okay, so from the vector DB, if the process is not good enough or it cannot able to get the proper context for the query, then definitely it is not going to generate the correct answer. So that's one point. And while doing document indexing, like you have definitely the business will have a lot of documents, so that documents has to be indexed, right? So while doing indexing, if you can't able to properly index the data, then obviously it can't able to get proper context while retrieving it from the vector database. Or if it's not getting proper context, then ultimately it will not get the proper results. So that's why I want to show you in a diagram. Like if you can see, so let us assume this entire thing as a corpus of documents which was there, and then the user asks a question, and only the relevant context has to be picked up from the particular vector database, right? If it is not, then obviously the context whatever you provide, it might be wrong, and ultimately the response will be a wrong response. Okay, so it depends. It all depends upon the way you provide the context and how relevant is to the user question. So if we can able to achieve that relevance from like more accurate or more relevant to the user question, then you will get a good answer. So that's the main goal, like how we can establish a good Retrieval-Augmented Generation in production. Okay. So now in order to do that, there are different processes involved here. Okay. So I will discuss some basic steps. Okay. So what we do, we take documents. Okay. So the documents may be either like it may be PDF. So most of the business documents will be in the form of PDFs. Okay. So these documents we call it as unstructured data. Okay. It is not a structured format. So the document may be in the text, graph, table, so whatever may be like in the document. So that one So how like if for example if you are going to um, 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 use PDF as a document and convert it into vectors and store into vector database, this process itself is a complicated process in such a way that you need to get all the information present in this particular PDF document in a right way and feed it into the vector database, right? So let us assume there is a document, PDF document, okay? So PDF document will have in different formats, a different way how they represent the paragraphs, the text or tables, okay? So let us assume it's a PDF document having a title and some paragraphs and some images here and some charts also here, okay? Let us take a typical financial document which consists of all these variety of components in it. So you should devise a way in such a way that the information present in this particular document is properly represented in the form of vectors and no information was lost during the during converting into vectors and storing in the vector database. So if you can able to achieve this one properly to the max of 95 to 98 percentage, so that itself will save you like will have you a good vector database representing your document, and that is a first step how you are going to solve this. Okay, there are different methods like you have to parse the text in these documents, and then you need to, if, for example, if the document has images, okay, let us have this document as images, and this image has to be converted into vectors, okay, and if this having a table or a chart, then that has to be represented properly in the form of vectors, such that the meaning of this particular chart or the image is not diluted or it's not corrupted when you convert that one into vectors and store it into vector database, right? So this itself like converting a raw PDF document into a lossless or with a minimal loss vector database itself is a process. So that we call it as a RAG pipeline, okay, where we convert the documents into vectors and store it in vector database. So here there are different processes. As I explained, if it is a pure text, okay, so you parse the text, and let us assume a document consists of 100 pages and each page having a paragraph of text. So how you cannot have all these particular a bunch of text and store it directly into vector database, right? We cannot do it. We have to slice the text, okay, into different chunks, and then only that part has to be converted into vectors and stored into vector database. While doing slicing, you have to consider like how you are going to slice, whether you are going to do with a paragraph or whether you are going to do any boundary line, or you are going to arbitrarily choose 1000 characters and text it and chunk it. So this all depends upon your use case. So all these things play a major role while developing a retrieval-augmented system. Okay, so here I just given you a overview like what is why we go for RAG. So the main use case for RAG, like with the plain vanilla large language model or generative AI, directly we cannot use it in our business. Why? So it doesn't have the knowledge of your own business or the privately available data, which is only visible to your own systems. So definitely that is not available in public. So if it is not available in public, then definitely the LLM cannot see your data, right? So that one, if you directly use that LLM which was trained in a public data set, you won't get answers for your own business data. Okay, so for that what we do, there are two broad ways how we can feed the business data. So one is fine tuning and one is RAG. Okay, So fine tuning, definitely we are not going to, there are cases where we can use fine tuning in special cases, and there are cases where we can use retrieval-augmented generation. So we also discussed about why fine tuning is not suited for all the use cases. Like the main thing is that it is costly and it requires technical knowledge, more technical setup, plus you need, for example, if data is continuously updating and you want to have more relevant data, then definitely it is not going to work in your business use case, because for every time if you need to fine tune, then it will require a lot of resources. So that is not the use case like what we are discussing now. For example, in your business use case, you are going to have your data updated regularly, then definitely we are going to use RAG. So RAG is retrieval-augmented generation. We saw like how actually we do retrieval-augmented generation. A simple frame like a setup like having documents, converting into vectors and using vector DB to store it, and then while user is asking a query, then it will be converted into vectors, and that vectors will be semantically searched along with the vector database, and related chunks are picked up, and then along with the chunks and user question are augmented both and given to the LLM. So LLM now has the data required for answering the user question. So it will give you the proper response based upon the relevant data what you gave to the LLM. Okay. So we discussed like how we can set up a simple RAG pipeline, but definitely this simple RAG pipeline is not directly usable in production systems. So I discussed also like if we have a PDF document, so how we can, because most of the enterprise have document in the form of PDFs. So these PDFs have enough, like this we can say it is a unmined data or dark data where directly it is not usable in the system. So somehow we need to convert into LLM usable data. If you can able to convert that one, then definitely you can build a AI system on top of that particular data set. Okay, so that's how we discuss like how we can set up a RAG pipeline, and especially on PDF, how we can do that and what are the parameters you need to consider. Okay, so I discussed about chunking, how properly you chunk it, and then apart from chunking, you also need to add metadata. So for each chunk, such that it is properly indexed, and then when you are querying, like when a user asks a query and the relevant chunks has to be picked up, so that one we can so these are the different parameters. So in the next video I will discuss in detail about how we can build a RAG pipeline, and then I will give you an overview and also a demo, so that you will get a clear understanding and how you can leverage large language models in your business use case, because each business has their own use case, and one cannot fit to the other one. So it has to be done in such a way that it will be, you get more value or most value from that particular setup, then only it will be useful. Okay, so you already know like most of the AI systems will fail in production. So why? Because it is not like these systems are not for like a general purpose thing. Like if it is a chat GPT, like you can just ask question and give you the answer based upon the data. But if you want to really get value for your own business, then it's totally different case. Like you need to have a setup in such a way that it should give you a proper response, or then only you can get value from that system. Okay. So thank you for watching this video.